Greetings of the day, everyone. Hope you are doing well. Let's start with today's session on Agentic AI Part 2, which includes the case studies of Agentic AI. So, primarily, we are going to discuss three case studies. One is AutoGPT, second is LangChain, and third is CrewAI. So, starting with AutoGPT. So, what is AutoGPT? AutoGPT is a first open source LLM plus autonomy experiment by OpenAI. It is used for multi-step experimentation, multi-step execution, and is one of the first open source experiment used to combine a language model with a true autonomy. Its impact was immediate and profound. Users could give it a simple prompt like help me start a business, and AutoGPT would use its own reasoning to break down that goal into steps, search online for relevant information, write files with business plans, and execute complex multi-step workflows entirely on its own. So while it was revolutionary, AutoGPT also had some risks, right? So the risks are as follows: risk and limitations. It often fell into infinite loops, hallucinated and gave wrong facts, lacked meaningful user control once it was started. So users sometimes found it burning through the API credits rapidly without actually pursuing the goals in a unproductive without actually pursuing goals in productive ways. However, AutoGPT's value wasn't in its stability or reliability, it was in sparkling imagination and proving that agentic workflows were no longer science fiction. It was the first demonstration that we could build systems capable of autonomous goal pursuit, even if the first implementation was rough around the edges. AutoGPT inspired an entire ecosystem of more sophisticated agent frameworks and established important conversation about safety, control, responsible deployment, and use of such tools on a wide stream basis. Now let's discuss some of the features and a comparison between AutoGPT and ChatGPT. So both AutoGPT and ChatGPT are OpenAI's frameworks, and with respect to the level of autonomy, AutoGPT breaks down tasks and self prompts to complete an overarching goal with minimum intervention from the user, while ChatGPT requires repeated human prompting and constant guidance. As far as context and memory is concerned, AutoGPT connects to vendor databases for long-term memory and allows it to remember past projects and preferences, while ChatGPT has a limited memory. Real-time data can be accessed by AutoGPT through plugins to get the up-to-date data, while ChatGPT has a knowledge cutoff date based on whatever version you are working with. Then there is an access, primary open source access for AutoGPT, which requires technical setup of the self-host through simpler web-based interfaces, and ChatGPT, though being user-friendly, browser-based chatbot, is accessible to the general public. So it's basically similar, but AutoGPT is open source, and ChatGPT in the premium version charges a subscription fee. So now let's come to the next tool, LangChain. LangChain has made agent development a practicality for everyone. So it's a development framework which is a modular abstraction with agent components. So it provides standardized interfaces for tools, memories, and chains, and it is an integration ecosystem for popular services and APIs. So LangChain emerged as a practical developer framework that made building agent systems accessible to a broader community. Rather than requiring teams to build everything from scratch, LangChain introduced crucial abstractions such as tools, chains, memory management, and agent logic. It provided standardized interfaces for integrating popular services and APIs, making it easier to prototype and deploy LLM powered agents by handling much of the complex plumbing work. Developers could now build everything from simpler from simple question and answer bots to sophisticated multi-step workflows with API access, search capabilities, and state management. While LangChain required significant engineering effort and wasn't a no-code solution like most of the solutions these days, it became a de facto standard in the industry for many early adapters and also spawned the entire ecosystem for extensions, integrations, and complementary tools. Its influence also extended beyond its own framework. It established patterns and best practices that influence other frameworks like LangGraph and AutoGen and help bridge the gap between research prototypes and production ready agent systems. Now, let's talk about some of the differences between LangChain and ChatGPT. So, again, LangChain is an open source software development framework, while ChatGPT is a proprietary and end user chatbot application. Purpose of LangChain is to build and connect custom data aware applications that use LLM as a backend component, while ChatGPT has a direct human like conversation to perform tasks with the user based on its general knowledge. So, LangChain uses LLM at the backend. For example, it can use ChatGPT as the backend as its reasoning engine. However, ChatGPT is itself the LLM. It is the core product. Then, as far as customization goes, LangChain is highly customizable, and developers can integrate their specific data sources like memory defined tools and create complex chains of actions. ChatGPT is also customizable. We can have custom bots and custom prompts, but the core behavior is defined by OpenAI. But we can have custom GPTs. Yeah. Then for data access, LangChain can connect to external data sources such as private documents, databases, and APIs. This is the core functionality which enables RAG, that is retrieval augmented generation. But RAG is not as such supported by ChatGPT. I think it's limited to data that it was trained on, plus whatever information that the user provides within the chat session. So, if you provide a certain information, that information may be used within the chat, but after the chat that information would be lost. So, that is the difference. And newer version though have internet browsing capabilities for ChatGPT. Then target user for LangChain was the AI developers, software engineers, and data scientists. ChatGPT is for the general public. Example use case, for example, for LangChain is suppose there is a customer service bot that you are building for your company that can search and answer questions based on a database of your internal product manuals. So that's very niche to your company. While ChatGPT can be, suppose there is a user who asks a general question that explain so and so process, write a poem on so and so, right? Then memory provides a variety of memory components for conversational context, allowing developers to choose the best strategy for the application. ChatGPT has a built-in memory, but that's only limited to the chat session, and of course it can refer to certain previous chats also, but earlier parts of the same conversation, not the previous chats, earlier parts of the same conversation. Ecosystem, again LangChain is an open source framework with wide range of integration with LLMs, data loaders, vector stores, and other tools, and it includes related products like LangGraph and LangSmith. ChatGPT on the other hand has a broader OpenAI ecosystem and supports plugins or responses AI for limited integrations. So, this is a very interesting architecture diagram for LangChain. Here we have some documents. Suppose there are PDFs. PDFs are broken down into chunks of text or chunks of documents and then converted into embeddings. These embeddings are stored in a vector store or a knowledge base. Now, suppose the user is asking a question. That question is first converted into a question embedding. That question embedding essentially is a vector form of the question. Then semantic search is performed based on the vector form of the question embedding, and the semantic search is, for example, a cosine search or whatever distance based search, Euler based distance search between the embeddings. Suppose whatever is the question, like question is what is a neural network, and there will be one answer, it's it's a set of nodes of artificial uh, um, intelligence network or something. So whatever is the ranked answer, ranked results that would be fetched, these ranked results would be provided to a LLM. LLM would then make sense of the answers and provide the final curated answer as the final answer to the user. So this is the basic architecture of a LangChain framework. Now let's come. No, you can of course absorb this for a minute till the time I go to the next one. Now let's go to the next one, which is CrewAI. So CrewAI represents the next frontier in agent development. It is not just single agents working alone, but teams of agents collaborating to achieve a complex objective. CrewAI allows you to assign different specialized roles to different agents, like planner who develops a strategy, a researcher who gathers the information, a writer who creates content, a reviewer who ensures quality. These agents can work asynchronously and pass results between each other to build each other's contributions, such like real world teams would operate. These approaches would enable parallelism in task execution, allow for deeper specialization in agent capabilities, and also can be used to handle complex objectives that would overwhelm a single agent. However, multi-agent systems also introduce newer challenges around coordination, ensuring agents remain aligned with the overall objectives and manage the emergent behaviors that arise from the agent interactions. Despite these challenges, CrewAI demonstrates how agent teams can go well beyond the limitations of individual assistance and tackle enterprise level challenges that require diverse skills and collaborative intelligence. So let's go through some of the differences between CrewAI and ChatGPT. CrewAI again is an open source multi-agent software framework for developers, and ChatGPT is proprietary closed source end user chatbot. Purpose for CrewAI is to build an autonomous workflow and solve complex multi-step problems. For ChatGPT is a direct conversation. CrewAI architecture is a team-based system of multiple specialized agents communicating, collaborating with each other, delegating tasks to each other. ChatGPT is a single agent system and it's not an agent per se. CrewAI customizable and ChatGPT is customizable only to the extent of the user prompts. CrewAI has access to custom and external tools. ChatGPT is it's contained within the chat interface itself. CrewAI use cases, for example, ideal for complex multi-step projects like automated research, creating content pipelines, performing data analysis, and orchestrating business intelligence. ChatGPT is suitable for simple single-turn requests, brainstorming ideas, and content generation. CrewAI is primarily for AI developers and engineers who want to develop and deploy their own sophisticated autonomous AI applications, while ChatGPT is for the general public, for casual users and professionals alike. So this is a multi-agent workflow architecture, as you can just see. So they are a group of agents, collaborating agents. There is a collaboration strategy, there are some communication channels, and there is a physical there is an environment, right? So suppose there is agent 1 which has some tasks allocated to it through the collaboration strategy, and it passes its messages to communication channel. So this communication channel can be push pull based messaging frameworks like M2M frameworks. It can be middleware messaging, whatever. So suppose this is a messaging framework, and agent 1 is pushing messages to the communication channel, and these messages could be then pushed back to agent 3, agent 2 based on whatever subscriptions they have taken. Then task assignment can also be done to agent number 2 from the task allocation collaboration strategy. Then there can be information sharding or knowledge sharding to agent 3 and agent 2, and knowledge base can be populated with updates and queries by these agents. and the physical environment can send some feedback to agent 1, and perception can be then fed by agent 1 to the physical environment. So this is basically a system. The set of agents, agent 1 to 3 are the set of agents which are interacting with the environment based on a collaboration strategy and based on internal communication through communication channels. So let's discuss about some of the current limitations of agent systems, core technical issues, hallucinations, task failures, infinite loops, and context loss. So despite the exciting potentials of agentic AI, it's crucial to understand the current systems which are still fundamentally fragile. Agents can hallucinate facts, fail to complete tasks that they are capable of handling, or get stuck in infinite loops trying to solve ambiguous problems. They depend heavily on the context also. They depend heavily on the context and the quality of initial prompts and instructions. Small changes in the words can dramatically affect their performance. They are also sensitive to the changes in the tools and APIs they depend on, and often struggle when faced with edge cases or scenarios outside the training experience. It's important to understand that these systems are not examples of general intelligence. They are sophisticated but narrow task specific workflows wrapped in conversational interfaces. Think of them as brittle beta collaborators rather than omniscient assistants. This doesn't mean that they're not useful, but it does mean that you need to approach them with realistic expectations, robust error handling, comprehensive testing, and ongoing monitoring to ensure that they're performing to their intended means, intended as intended. Yeah. So those are some of the current limitations of agentic systems. We also have planned a part 3 of this sessions. We would be covering the rest of the topics related to autonomy and safety risk, framework and development challenges, risk management, paradigm shift, emerging implementation patterns, product team competitive advantages, leadership, and executive debate framework. So these are some of the other topics related to agentic AI. We'll be talking about these topics in the next session. Thank you. Hope this session was informative. Bye.